Welcome to Genius Plus Twins. I'm Mrs. Fidel, and today we're going to compare and order improper fractions and mixed numbers. The first thing we're going to do is learn how to compare these numbers. When you look at two different diagrams, diagram A and diagram B, you need to think carefully about which one represents a greater value. Visual representation can help us understand the size of fractions more clearly before we work with the numbers themselves. Looking at diagram A, we can see that it represents the improper fraction 8/5. This same quantity can also be written as the mixed number 1 3/5. These two forms are equal to one another because they represent the exact same amount, just written in different ways. An improper fraction has a numerator that is larger than its denominator, while a mixed number shows the whole number part separately from the fractional part. When we examine diagram B, we see that it represents 7/6, which can also be expressed as the mixed number 1 1/6. Again, these two forms are equal because they describe the same quantity. To compare which diagram shows the greater value, we can look at the mixed number forms since they're often easier to understand. Diagram A shows 1 3/5, while diagram B shows 1 1/6. Since both have one whole, we need to compare the fractional parts. 3/5 versus 1/6. 3/5 is significantly larger than 1/6, so diagram A represents the greater value. We can see that 3/5 is more than half, while 1/6 is well less than half. Therefore, we know that 1 3/5 is greater than 1 1/6. Now, let's learn how to order these three improper fractions by converting them to mixed numbers first. We have 18/7, 17/5, and 14/9. The key to ordering these numbers is to change them from improper fractions into mixed numbers, which will make it much easier to see which values are larger or smaller. To convert an improper fraction to a mixed number, we need to think about how many full groups fit into the numerator. In other words, we ask ourselves, how many complete wholes can we make from this fraction? Let's start with 18/7. Think about it this way. How many full sevens are in 18? We know that 1 7 is 7, and 2 sevens would be 14. Can we fit another full 7? No, because 3 sevens would be 21, which is more than 18. So we can make 2 full wholes from 18 sevenths. After we take out those 2 full sevens, which is 14, we have 4 left over. This leftover 4 becomes our numerator, and we keep the denominator of 7. Therefore, 18/7 equals 2 4/7. Next, let's convert 17/5. Ask yourself, how many full 5s are in 17? 1 5 is 5, 2 5s are 10, and 3 5s are 15. Can we fit another full 5? No, because 4 5s would be 20, which is too much. So we can make 3 full wholes from 17/5. After we use up those 3 full 5s, which equals 15, we have 2 left over. This means 17/5 equals 3 2/5. Finally, we convert 14/9. Think about this. How many full 9s are in 14? We know that 1 9 is 9, but 2 9s would be 18, which is more than 14. So we can only make 1 full whole from 14 ninths. After we take out that 1 full 9, we have 5 left over. Therefore, 14 over 9 equals 1 5/9. Now, we have our 3 mixed numbers, 2 4/7, 3 2/5, and 1 5/9. To compare these numbers and put them in order from least to greatest, we start by looking at the whole numbers first. This is the most important step because the whole number tells us the overall size of each number. Looking at our whole numbers, we have 2, 3, and 1. The smallest whole number is 1, which belongs to 1 5/9, originally 14 over 9. The next whole number is 2, which belongs to 2 4/7. Originally, that was 18 over 7. The largest whole number is 3, which belongs to 3 2/5. Originally, that was 17 over 5. Since the whole numbers are all different, we don't even need to compare the fractional parts. The whole numbers alone tell us everything we need to know about the order. When whole numbers are different, the number with the smallest whole number is always the least, and the number with the largest whole number is always the greatest, regardless of what the fractions are. Therefore, in ascending order, from least to greatest, we have 14 over 9, then 18 over 7, and finally 17 over 5. This is how we successfully order improper fractions by first converting them to mixed numbers using mental math to figure out how many full wholes we can make, and then comparing their whole number parts. That's all for now. Until next time.